Hey, what's up guys? Welcome back to Josh Does Coding. And today we are going to be starting a new AI series where we create a more advanced AI from scratch. We're going to cover things like behavior trees, tasks, decorators, environment query systems, and all of that good stuff. If you don't know what anything I just said meant, don't worry, we will cover it all in this series. So let's just hop straight into it. Today we are going to be setting up logic to get a enemy patrolling. So I just have a blank project here. I just created this map. And what I'm going to do is I'm going to go ahead and create a new folder and I'll just call it AI. Of course, you don't have to do this, but for sake of organization, I'm going to do this. And here I am going to create another folder and I will call this, let's just say AI character. We're only going to have one, so we don't have to be too specific. And in here, we are going to go ahead and make a new blueprint class. And we are going to make a character because a character is a type of pawn that includes the ability to walk around. And we are going to want our AI walking around. So we are going to call this BP underscore, let's just say AI character. Of course, you are free to name this whatever you want. We are going to open up the character. So the first thing we're going to want to do is throw a mesh on here. So I'm just going to throw in this orange, yellow, person that the engine gives us. And we'll just rotate him so he's facing forward. For those of you who don't know, this little blue arrow here represents forward. So we'll just compile that. And what we can do now in our character movement component out here in the components tab is we can search for, I believe it is walk. Yeah, if you just search walk, here we can set a whole bunch of walking settings. The thing we're going to be looking at here is max walk speed. Now you can set this to whatever you want. So as you can see, it's in centimeters a second. By default, it can travel 600 centimeters a second, which is 6 meters. I'm not sure what that is in feet. So you can change this to whatever you like. I'm going to leave it default, but I did just want to showcase this in case you were wondering how to change the walk speed for when it's patrolling. But now we can just go back to our content browser. We'll go back to our AI folder and we'll create a new folder and I will call this behavior trees. Now, if you right click, you can come to artificial intelligence and you'll see a behavior tree. I spelt behavior a bit differently. We'll ignore that. Ignore me. We'll say this is BT underscore. I'll just say AI character again. We don't have to be too specific because I only have one character, but again, you can name this whatever you want. So, for those of you who don't know what a behavior tree is, it is essentially a way of executing logic on an AI. So, you have this root node, and this is the start of our behavior tree. So, if you drag out, just like a blueprint, you can drag off the bottom of it, and you can get a new node. So you have three options in behavior trees. You have a selector, a sequence, and a simple parallel. A selector will select the first task below it that succeeds. A sequence will go through every task below it until one fails. And a simple parallel allows you to execute a secondary task while your main task is going on. Now we'll explain these more as we use them, so don't worry about that. But the first thing we're going to want to do is a selector. And we'll just call this node name. If you select the node on the right here, you get node name. We'll call this main. And basically the reason we do this is because we're going to have options under here to patrol or wait. And we're going to want to select the one that's only one of them to do at a time. So what we'll do is we will drag out from the bottom selector here. And now you see we have a whole bunch of tasks we can do as well. Again, we'll cover everything eventually. Before now, we're going to want to do a actually let's from main, let's drag out a sequence and we'll call this patrol. Now again, we do a selector, so in the future we can say, if the patrol sees somebody, stop patrolling and go chase him. That's why we have the selector here. So behavior trees execute top to bottom and left to right. So for example, you can see here, this is 0. That means it's the first node that's going to get executed, and this is 1, so it's the second node that's going to get executed. Just as an example, if I drag in another selector, you see it is 2, but if I drag it to the left, it now becomes 1. So again, you execute top to bottom, left to right. All right, so from our patrol node, we are going to start by doing a move to task. If you don't see tasks, you might just have to click the drop down and select move to. Now, on the right side here, you'll see that there is an acceptance radius. So this is how close the AI needs to get to the target before it considers it reached. This is a filter class. You can throw in your nav filters here. Allow strafe, reach test. We'll cover all that eventually. None of this is super important today. So the main thing is that you'll see this blackboard key. Now this blackboard key is looking for a location to move to, which we currently don't have any way to pass in. How do we do that? Well, the answer is you create a new blackboard. So we're going to come here. We're going to create a new folder. Again, if you didn't see, I just hit new blackboard. And in this folder, we're just going to call it blackboards. And inside of here, we'll create our BB underscore, BB for blackboard, underscore AI character. Now in the top right, you will see that we can switch to blackboard mode. So if you click the blackboard, we now have our blackboard. And here you'll see by default you have a self-actor key, which just represents the AI character that this behavior tree is running on. So we're going to select new key. We're going to come down to vector because a vector is a location. And we'll call this patrol target location. You can call this whatever you want, of course. So once you've added your vector and named it what you want, we can save and we can come back to our behavior tree. Now on the move to node, if you come to the blackboard key, you can select our patrol target location. And that works perfectly. Now, the issue is, well, how do we set our target location? Well, there's a few ways we can do it. We are going to create our own blackboard task. Again, if you look at the task the engine provides, there's none here to get a location. So we're going to have to create one ourselves. So if we come to our content browser, I'm going to create yet another new folder, and I'm going to call it, I'll just call it tasks. You can call it whatever you want, behavior tree tasks, AI tasks, whatever you want. Now, it isn't actually under artificial intelligence. You have to create a new blueprint class. And you'll, at the bottom here, click the all classes dropdown and search for BTT. And you'll see this BT task underscore blueprint base right at the bottom that you're going to want to select. And we're going to name this BTT, or behavior tree task underscore get patrol location. Now, if you open this up, you'll see it's essentially a normal blueprint, but we'll have a few different options available with this. So the first thing you're going to want to do is right click and search for events um, receive executes AI or events receive executes. The main thing here is receive execute AI will give you the controlled pawn and the owning controller that is executing this, whereas event receive execute will just give you the owner actor. We're going to use execute AI. That's my personal preference, even though we might not need these here. So essentially, this event gets called when this or when a node here gets run, it fires this. So what we're going to do is we're going to get our controlled pawn. We are going to get actor location. So we're getting the location of the AI that is running this behavior tree. And then we are going to get, I will say, random float in range. And then what we can do is we can split this pin to get access to the X, Y, and Z values. And we can just get a random value for each of these. Or what you can do, which I suggest we do, is we search for get navigable, get random location in the give in you know what? I'm not even going to try, guys. We're going to want to get this random location in navigable radius, and we're going to connect it to event execute AI. Now the difference here is that this will work. It will give you a random location. However, that random location might not be somewhere that the AI can reach. So this node will make sure that where your AI is trying to go, it can actually reach. So for the origin, well, once again, we're going to get our controlled pawns actor location. So the origin will be where our AI is currently standing. And the radius is how far around this point you want to look. So we'll say 500, which is 500 centimeters. We'll make it 1,000, which is 1,000 centimeters or 10 meters. And then here you can add your nav data or filter class. We'll cover those later in the series. We won't worry about those right now. So our return value, we have the location and we have this Boolean. The Boolean is if it was able to get a location to move to. So we'll drag out and do a branch from this Boolean return value. So if it wasn't able to find a location, so if false, we are going to call finish executes. And you'll see on this node you have a Boolean success. We're going to say it failed. So we are not going to hit this checkbox. If it was unable to get a location, it did not succeed. Now, if it did succeed, if true, what we're going to do is we're going to say that we want to move to this location. Now, to pass this vector into our behavior tree, we need to create a variable, and we'll call this patrol target location. And we don't make it a vector, we make it a blackboard key selector. Now, it is extremely important to the right of this variable, you hit this little I so that the variable is public and can be editable. Now, that's extremely important because if you don't hit this, it will not show up in the behavior tree. So again, make sure this I right here is open. Perfect. So what you do is you can now drag this in and get it. And then you drag out of here and you do set as vector. Set blackboard value as vector. If true, we will pass in this random location. I'm going to do a reroute node just so we're not going through our code here. and I'll pass that into the value of the blackboard key. Now, once that is set, we can once again call finish executes, and this time we'll say it was a success, so we'll click this checkbox. And there you go. We now get our current AI location, get a random point around that AI, and we will set the value if we were able to find one, and if not, we'll say the task failed. So once you compile and save this, we can go back to our behavior tree. And now when we drag out of patrol and look under tasks, you'll see our BTT get patrol location. So we'll drag this in and we'll put it to the left of the move to, because again, behavior trees execute top to bottom, left to right. So we want to get the patrol location before we try to move to it. So we put it to the left. Now, remember that blackboard key that we made as a variable? Well, if you look in the details panel, we will now see that we can set this. So we're going to want to set it to patrol target location from our blackboard that we made earlier, this patrol target location. So now, since we set this as a vector, when we pass in our patrol target location from the blackboard key, its value is being set to the value we set here. So now this task will successfully get a patrol location. We'll then move to that patrol location and it will repeat, which is perfectly fine, but we want it to have a bit of a delay when it gets there. We don't want it to just be constantly moving. So to the right of move to, we will add a wait task. Now in the details panel, you can say how long you want it to wait, and you can add a random deviation. So wait time, for example, we can set this to 3. It'll wait 3 seconds. Now if we add 1 to our random deviation, it will be 3 seconds plus or minus 1, which means it can be anywhere from 2 to 4 seconds. Now you can set these values to whatever you like, of course. And that's perfect. We now have our behavior tree getting a patrol location, moving to the patrol location, and then waiting before trying to do it again. Now, we actually need to tell our AI to run this behavior tree. So what we'll do is we will, in our event graph, we will get AI controller, and the controlled actor we'll drag out and do self. And then from the return value, we'll say run behavior tree, and we'll hook this up to event begin play. Then in the BT asset, you're going to want to drag in your behavior tree, or select your behavior tree, apologies. And then on begin play, your AI will now try to run this behavior tree. So we can now compile and save our character, and all the logic should be set up and good to go. The last thing you'll need to do is in our Place Actors tab, back in your scene, you're going to need to search for a nav mesh bounds volume. And a nav mesh bounds volume is Unreal's basically built-in navigation system. So an AI, in order to move around, needs a nav mesh bounds volume, and it can move around anywhere inside of this cube. A way to check this is if you hit the P key on your keyboard by default, you'll see this green, sort of color wherever there's a nav mesh. So this green, by pressing the P button on your keyboard, will show you where your AI can walk around. Now we want our AI to be able to walk around this entire level. So in the details panel for our nav mesh bounds volume, we're going to come to brush settings, and we're going to increase the X just so that it covers the whole area, X and Y. And you can see the entire cube is now green, which means our AI can walk anywhere here. If you want to disable the nav mesh visualization, you can press P again. Now, if we drag our AI into the scene, our AI character, and we run it, we'll just eject here. You can see our AI is going to move to a location. It's going to stop. It's going to move again. It's going to stop. It's going to find a random point, and it's going to move again. So that is the basics of getting an AI to patrol an area. Of course, there's various ways you can get AI to patrol, whether it patrols between certain points or just completely random like this. We'll set up a more advanced patrol in the future. So if you do want to see that, be sure to leave a like and subscribe so you don't miss the next video in this series. If you have any questions, be sure to leave a comment down below and I will help when I can. And I hope this video has been helpful to you guys, and good luck with your games.